Welcome to the weekly webinar, where QuickSight customers will learn about product functionalities, new feature launches, best practices, and tips on how to improve the user experience, and also gain technical knowledge from QuickSight solution architects and product managers. In today's session, we will be learning about visualizing data in QuickSight using Athena Federated query. My name is Salim Khan, and I'm a QuickSight Solutions Architect at AWS. I have my colleague Neeraj Kumar, who will be presenting with me today. And we also have Deepak Singh with us, who will be moderating the webinar or responding to the questions you'll be posting in the community. So now, where do you go if you have questions about QuickSight? The QuickSight community is a place to connect with other QuickSight users, and it is the first place you should look for answers to your questions. You can search for answers, ask new questions, connect with other users, and find new resources. We also post all the latest announcements, blogs, learning resources here, including many examples that are created by me and my colleagues are in the Demo Central section. So if you haven't done so already, now would be a great time to join the community and bookmark it for future reference. Once you are on the community page, here is what the Q&A section looks like. You can search at the top, and if you don't find an immediate answer, post a new question. You do need an ID to post for the first time, and this will require an Amazon.com login. And to make sure our experts on this live session get an answer to you quickly, use the hashtag QLS-AFQ-WITH-QS, and we'll be prioritizing these questions all day today. So today's session will be recorded, and we'll have this posted to our YouTube channel and community by the end of this week. We are celebrating a year of QuickSight community. At this point, I would like to call on Kristen Mandia, who was our online community manager, and to say a few words. Kristen, over to you.
Thanks, Salim. Hi, everyone. I've met many of you, so it's great to be here. As Salim mentioned, we are at our one-year birthday, and we are thrilled to continue the celebrations we started last week over the next month. As you know, the community is our one-stop shop for all of our QuickSight learning resources. Over the past year, we've had thousands of people sign up and hundreds of thousands of visitors each month. And we have thousands of questions and answers to those questions posted on the community. Many thanks to our solutions architects like Salim and Neeraj and Deepak for responding to those questions, and also to our experts who are listed on our birthday website page. We have hundreds of learning resources, including getting started resources that Salim has created, how-to videos and articles, and events for learning enablement. And we hope that you'll be able to participate and learn from all of those resources. In addition to celebrating the launch of our community website, we want to celebrate each of you today and the people that make our community so great. We'd love to hear from you about the QuickSight community and what you'd love to see over the next year. So sign up for the community and post a reply on our birthday page today. If you do that today, we would love to send you some swag for a limited time while supplies last, if you're able to post and let us know what you'd love to see. I'll put the link in the chat. Thanks, Salim.
Thank you, Kristen. So for today's agenda, we will be quickly covering through all the QuickSight native data sources. We will go through an overview of Athena Federated query, which we refer to as AFQ2. We'll quickly do an architecture overview of what we are demoing and presenting today. Set up AFQ with Google BigQuery, with Microsoft Azure Synapse, and Amazon DynamoDB. And then we'll get into the demo of showing you how we are creating data sets with multi-cloud data sources. Also create a QuickSight analysis using all these data sources, right? And towards the end, we will look on some key considerations that you should look for when we're doing multi-cloud analytics, and some of the the challenges that you might face and how to go about it, right? And then we will finally end up with a Q&A session. Okay. So QuickSight can connect to data on-prem, in AWS, and from SaaS applications. So QuickSight is natively integrated with AWS data sources, as well as on-premise and hosted databases and third-party applications. These are some of the native data sources that QuickSight connects to, right? So the data sources that QuickSight does not connect to natively, we can actually use Athena Federated query to connect to those data sources, right? And that is what we're going to cover today. So what is Athena Federated query, right? So Athena uses data source connectors that are internally using Lambda to run federated queries. Right? So data source connectors are pre-built and can be deployed from the Athena console or from the AWS serverless application repository. Based on the user submitting the query, connectors can provide or restrict access to specific data elements. When a federated query is run, Athena identifies parts of the query that should be routed to the data source connector and then runs them with Lambda. The data source connector makes the connection to the source, runs the query, and returns the results to Athena. If the data is not fit into the Lambda RAM runtime memory, it fills the data to the Amazon S3 bucket and is later accessed by Athena. Okay. So for today's demo, I'll quickly walk through the architecture overview of what we're trying to do today. So in order to explain this architecture, let us walk through a sample use case of analyzing like daily fitness and daily nutrition data of users. The sample data set on Microsoft Azure Synapse Analytics contains users' fitness information, like the daily run stats in miles, the calories burned, the average heart rate, like average speed, along with some hours of sleep. The sample data set on Google BigQuery contains the daily nutrition data, which gives us the calories intake information. We also have the user profile that is stored on Amazon DynamoDB. All these three different data sources can be connected to QuickSight using the Athena Federated query. As part of the demo today, we will join all these data sources in QuickSight and run queries on the joint data set to derive insights like the calories burned, which come from Azure Synapse, and the calories intake that comes from Google BigQuery, and then visualize them in QuickSight. So the key part of this architecture is the Lambda connector right in the center that basically connects to the data sources and provides the information back to Athena and then to QuickSight. Some prerequisites that will come in handy once we are actually setting up the connectors. So the Amazon S3 spill bucket will need to be created. That is used by all the connectors like the Azure, the BigQuery, and the DynamoDB. For Azure, we need the JDBC connection string for the Microsoft SQL pool. We also need the VPC security group ID and the subnet ID for the VPC that the Lambda connector will be deployed to. Right? For Google BigQuery, we need the GCP project ID. Okay, and the same goes for the Lambda connector's VPC security group and the subnet ID. Right? For DynamoDB, we just need the S3 spill bucket information. Okay. So as part of the demo, we will first set up the Athena Federated query with Microsoft Azure Synapse. Then we will go ahead and connect Athena to Google BigQuery, then set up the federated query with DynamoDB. After setting up all these connections, making sure that Athena can talk to these data sources, we will then connect QuickSight with Athena to get information from these data sources from multi-cloud, right? And then we will actually build an analysis on these different data sources and show how it can be done in real time. Okay. So the first setup is basically connecting Athena Federated query to Microsoft Azure Synapse. Okay. So I have my Azure console open. So I'll quickly show where my data looks like. So I have a demo SQL pool. I have my AZ Fitness daily summary data that I have. So we just select the top 100 rows and see how the data looks like. So see, I have the activity date and some other information like calorie, time in bed, average heart rate. All this data is basically in my Synapse SQL pool, right? What we need from here is basically the JDBC connection string that we were referring to as a prerequisite. So you can get the information, click on the link, and click on the JDBC tab. Okay. Yeah, and make sure you have this and keep it so that we can actually use that when we're configuring the Lambda connector. So we need to first create the S3 bucket, quickly create my S3 bucket for the spill data. So I'll be calling it AFQ00 spill 2023. For this demo, we'll leave all the other settings as default. So we will also be creating the same S3 buckets for BigQuery and DynamoDB also. So once the S3 bucket is created, we will go to the AWS serverless application repository. So we'll be using the serverless application repository to create the connectors. Okay. Clicking on the available applications, you make sure that the show apps that create custom is selected, okay, and then search for Synapse. Okay. Make sure the Synapse connector is verified author, and then click on the connector. This will take you to the configuration screen, right? So we'll start entering all the configuration parameters to have the connector connect to the federated source. Okay, so we'll give a secret prefix name. We will get the JDBC, that connection string that we had gotten from the SQL pool. Paste it in here. We will provide the Lambda function name. Leave the memory and the roles as default. Put in the security group ID from the VPC. Provide the spill bucket name that we just created before this. Okay. We can leave the spill prefix as failing and just get the subnet ID. Once done, you click acknowledge and click deploy. So once the function has been deployed, you'll see that the status will change. Okay, once it's changed, we can click on functions. Okay, and open up the Lambda function that got created. And on the configuration tab, we will go to the environment variables and edit that and add one more environment variable. So this is the Azure connection string, demo connection string, and the value for it is exactly the same default JDBC connection string that we had gotten before. You click and save that. Once the function is updated, we can quickly go to Athena. Okay, and now create the data source in Athena. Click the create data source and then look for Microsoft Azure Synapse. Click next. Yeah, and we will give in the I try to keep the name of the Lambda and the data source function same. So we'll give it as AFQ Azure demo. Select the Lambda function that we had created. Okay. And then click next and then create data source. So now the Lambda basically discovers the schema. In Azure ICMR schema has been discovered. This is an important step. Once this is out here, you can actually go into the query editor and see if you can pull the data from this data source. So we'll select the AFQ Azure demo, and we see our schema has been listed, all the tables for the schema. We'll quickly do a preview. Let's see if we can view the fitness data in Athena. Once this is done, we know that Athena can connect. Okay, and we can move on to the next. Now we've connected Athena with the federated data source to Azure Synapse Analytics and be able to view the data in Athena correctly. Okay, so that setup is done. Now moving on to our setup 2, which is setting up Athena federated query with Google BigQuery. So let me bring up my GCP console. So you see, I have my project on my GCP console, and I have my healthcare database, and I have a table which is called the daily nutrition data in Google BigQuery. I'll do a quick check on how my data looks like in the table. Select star from daily nutrition data, run the query. You see, I have all the calories information of all the meals that I've been taking on a day-to-day basis. Okay, so now once I have my data properly in my GCP project and table, now I move on to the console. We'll go on and configure the serverless application repository again one more time, for this time for GCP BigQuery. Okay, click on the applications, show that it's selected, and type the name of the connector. Sometimes the connectors are case sensitive, so make sure you're typing in the correct case for the connector. Once the connector loads up, make sure it's AWS verified author. Click on the connector. Okay, and go through the same configuration for Google BigQuery. The configurations are a little different. You'll provide the spill bucket for BigQuery. We don't need the endpoint, that's optional. What we need is the project ID. So I can plug in my project ID. Give a name to my Lambda function. I just put in as 2456. Leave the memory default, all the other 6 as default. We'll give a secret min prefix. This is where the GCP's secret will be stored. And then plug in the security group IDs and the subnet IDs for the VPC where the Lambda is deployed. Click acknowledge and then deploy. Once the deployment is fine, we can click on functions and then make sure the function is there and quickly go to Athena to create the data source. Okay, click on the data source, okay, create new data source, and look for Google BigQuery. And then click next. Enter the name for the data source. Search for the Lambda function, which is Lambda 2456. Okay, click next and create data source. Once the schema discovery is done, we can quickly go to the query editor. Select the data source, which was AFQ BigQuery demo. Make sure the database is selected, and then we have a table. We can do a quick preview of the table. Let's start from daily nutrition data, and then we can see if the table loads up properly. This is an important step to connect before connecting to QuickSight, right? So now we see we have all the data, and we have connected to Google BigQuery using the Athena federated query. So now Athena is able to connect perfectly to all the federated data sources. So we've connected Azure to get our fitness data. We've connected BigQuery to get our nutrition data. Okay. Now moving on. As step 3, we will basically connect Athena to DynamoDB. At this point of time, I'll like to pass the ball to Neeraj, who'll be setting up the connection with DynamoDB and then building the analysis and data sets in QuickSight. Neeraj, over to you.
Thank you, Salim. Let me share my screen and then you can confirm me.
Yes, Neeraj, you can see your screen.
Wonderful. Thank you. Hi, everyone. This is Neeraj Kumar. So as Salim has called it out, as a next step, we will connect with the DynamoDB using our Athena federated queries. So to start with the DynamoDB connector, first, just wanted to call out the prerequisite. Salim has already brought it up, but just I wanted to emphasize on that. So you need a S3 bucket where the data connectors would write to this particular spill bucket. You would also need a table, the DynamoDB table, where the data, where your data resides. And then once this is all done, we can create a connector. And then once the connector is created, we can build a data source within Athena and pull the data in. So let's start with that step. And again, it's similar to that, but it's slightly a few configurations. And that's what we will go and revisit those steps and then build a connectivity to Athena DynamoDB. So very first thing is to search for serverless application repository in your AWS account. So in this case, I have that already in. I can click on that, and then I can look for available applications here. And when I do that, I can search for I can make sure that show apps that create custom IAM roles or resource policies is marked here. And once it is there, then I can search for Athena DynamoDB connector here. So let me just type in here Athena DynamoDB connector. So based on the search, it has provided me these two options, and we should pick the one with AWS verified author tag, and that's the one we can click on that. And for now, once we click on that, it provides a template, and as we have seen for the other two connectors, similarly, we need to provide all these details here. So one is on the spell bucket, so which we can pick the spell bucket as we already have that created and provide that. We can provide the catalog name for our Lambda function, which in this case, I can give that name as Dynamo. All the other settings remain as is for spell encryptions and Lambda memory and Lambda timeout. We can keep that as is and spell prefix. And once before deploying, I can acknowledge this particular app to create custom IAM roles and policies. And then with that, we can click on deploy. Once we click that, the DynamoDB again connector will get deployed within your account. So it takes about a minute for approximately a minute for your connector to get deployed. And once the connector is deployed, and we can keep a track on that, like how it is progressing. So it seems like the status shows that it is it's in progress right now. Once this is done, we would be able to proceed with our next step, which is about creating a Athena data source. Again, Athena would use the data source connectors that run on AWS Lambda and would run the federated queries here. Again, just to call out, a data source connector is a piece of code that is translating that can translate between your target data source and Athena. And you can think of a connector as an extension of your Athena query engine. So with that, now seems like my deployment is done. Athena connector is established here. With that is being done, I can get into the Athena and I can create a data source here. I can click on the data source and so look for Amazon DynamoDB, which is my options. Once this connector, I select that, I can click on next and then provide my data source name. So in this case, I can provide as Athena federated query as an example, and then DynamoDB demo, that's the name. And then we have to pick the connection details, the Lambda functions that we just created it using our Athena, using the serverless application. Since it is being deployed, I can pick that Lambda function. And with that, now I can click on next here and create the data source. The data source is successfully created. Now I can query my data and look for my data source, which is now being created here. Seems like I can now access the user profile table, which is already created in my Lambda and my DynamoDB. So whatever entries are there as part of that, I can easily, I can see now in the Athena. So I can preview this table, and as I do it, I can see all my entries coming through. So it is going against the Lambda function is again querying the data and passing it to Athena. Athena is now we can preview the data within Athena. So with that, now we have established the connectivity. We have set up the 3 connectors. Salim has worked on, showcased you on the Azure Synapse and BigQuery, and now we have also established the connectivity to our DynamoDB. So all the 3 data for the fitness data, the nutrition data, and this is more of a user profile data. So we have that data. So we can pull down all these data and create a data set within QuickSight and create insights on top of it. Before we do that, there's one key steps to do within QuickSight, and that's more to do with the security and permissions. So since we are using a Lambda here, so we need to enable that within our security and permissions. So for that, your admin should be able to go into Manage QuickSight console, go into the security and permissions, and then within that, you should get into the Athena, and we can look for Athena connectors. And then here, I have all these S3 buckets, which I needed for my data to access. Also, from the Lambda point of view, I can check my Lambda functions. Once that is done, I can finish that, and then I can save it. So with that, I will be able to connect to my Athena data source from QuickSight and pull the data in QuickSight. Now, as the next step, since my connectivity is being done, I can go into and start creating my data sets. So for that, first step is to create a data source. So I can go in and pick the Athena as my data source. I can provide the name as, like, say, multi-cloud as my data source name, validate the connection, create my data source here. And once I'm in here, now I can look for my 3 connections that we have already established. So first one was like the Azure connections. I can pick that one, go into the database within that catalog. So it will provide me a list of the database, which is DBO. And within the DBO, I can look for a table, AZ Fitness Daily Summary. That's the table. And I can edit and preview the data. So now it's going to, QuickSight is rendering the results using the Athena Federated queries, which we have already established. So we get all the fitness data from Azure. Also, if you see here on the left side, I have activity date and all my metrics coming in. The one thing to note here is activity date is a string. I can convert that into change the data type to data, or I can also create a calculated field or utilize the functions within QuickSight. So taking an example here, like I can just edit this particular field as, let's say, activity date string. And once that is done, I can go and create my calculated field. Just in case if you wanted to have both the fields, the source field and the transform field, in that case, you can go and use the pass state functions, which will take your string. And then in that case, I have activity date string. I can pass that. I can have what format of date I'm looking for. Let's say MMDD YY is the format. And with that, I can save that, and which will provide me a calculated field on top of it. So that's how you can create a calculated field within your data sets as part of your data preparation. Also, you can add another data set. So in this case, let's go and add a data source, which is again multi-cloud, which we created just now. And I can I can go into a specific catalog. This time, let's say I wanted to bring in the nutrition data, which is a big query. And once that is, I can look for a database now. Database that we created some time back was a healthcare data. And we can point to that and pull in the table which has the nutrition data. As we do that, it will bring my nutrition data as well, and we can start joining these two. So we have a members ID, like for which the fitness data snapshot is being captured, and also the nutrition data has been captured. So we can pick the ID, and based on that ID, we can join that. So these are the two IDs. This is just a prefix just to understand that the data is coming from global BigQuery. Same way, if you have a multi-cloud data sources coming in, the recommendations would be to add a prefix so that as an author or as a data modeler or while I'm building, the authors would understand where the data resides or which particular data source it is coming from. So in this case, that was the intent. I can now pick up a join that I wanted to. Let's say I wanted to do an inner join, and I can classify that and apply that. So inner join gets applied to this connection. We also created a data user profile data. So let's pull that in as well. So I can go for that into a data source again, go again, pick my data source. And here in this case, now DynamoDB is the next one where my user profiles are added. I can pick that, and I can pick the table. So user underscore profile is the table, let's say, and then I can add that. Similarly, I can define what join would be here be driving it. Again, I can pick the ID field from both sources. And based on the use cases we can, in this case, I'm just going for an inner join and applying that. With that, now all my attributes across the sources would be pulled in, and I can query the data, create my insights on top of it. Also, I can one more thing we can find it out is like all these attributes are pulled in from the different sources. First stack was more from Azure, second was from Global BigQuery. If you see, all has a prefix for GBQ, and then the user profile table. If we wanted to change that, again, we can add it the name and make it as more of a user ID. And also, if there are fields we wanted to exclude that, for example, date of birth, if we don't need or any other fields we can just exclude that. We are not doing it now for this exercise. Just let's focus on like creating a data sets out of it. So we can query the data using the two modes, query mode as well as this the spice. So direct query is like putting the data as and when the interaction is happening on the dashboard or your analysis, it will always, based on the filters and navigations, it will pull the data in for you. Also, you can go for a spice, which is a super fast in-memory calculation engine. We can opt that and pull the data in. So basically, in this case, we will be able to pull the data into our spice. And again, it will give a more advantage from the point of view, like you can, once the data is cached in, you will be able to create insights. The queries are not going to run against the sources. Again, in this example, since it is a multi-cloud, it will be more cost effective if you pull the data in at, let's say, daily in the morning, or the nutrition and all the fitness data. Once that is being pulled in, you can just, or you can set up a refresh every hour or so. It's not like users have to, as and when they are querying it, the queries are going against 3 different sources and adding more cost to, or the resource consumptions could be higher on that. So you can reduce that. You can optimize that using our super fast in-memory calculation engine. So we can hold the data, cache the data for you. All the results will be in Spice, and the insights will run on top of the Spice. So let's, since I have saved it, I can look into my data sets. So since it is in refresh, it would take about a couple of few seconds more to pull the data in and have it in Spice. Also to highlight here, like you can create, if there's a need of creating a row level securities, you can apply that. You can also refresh. You can set up the refresh interval of your Spice data. in this case, if you wanted to do a full refresh or you wanted to set up an incremental refresh, you can very well do that. You can set up those schedules. You can always allow the users, you can share this particular data sets with other users within your organizations. And also this will provide you more on the usage side. If this particular data set is going to be used by multiple analyses or dashboards, this is where it will list out what the usage looks like, right? So once this is done, seems like we have now the data loaded. So we are good with all the data from all the 3 cloud sources. And now, since it is ready, we can go and start building our analysis. Let me start create the analysis. As I'm into analysis, it gives me an option right now to create an interactive sheets or go into the paginated reports. So if you, in case if there's a need of creating the paginated reports, you wanted to use and you wanted to send out those as an email or as a distribution, you wanted to set it up, you can always go and create the paginated reports. You can define whether it should be a portrait or landscape mode, or we can create also an interactive sheets or the dashboards. So in this exercise, let's pick up the interactive sheets and create analysis. And here, as I go in and create my analysis, I can pick the attributes, or also I can set up any parameters or controls. So let's start with creating a one parameter. So I want each and every person IDs to be picked up as parameters, and as we select a person, member's ID or the person's ID, it should show me the fitness detail or the nutrition details. So that's an objective as for this exercise. So let's create that parameter and let me put that as a number. And I can provide a default value, I can leave it. So I just have one person ID for this exercise, which we are going to focus on. And this is person ID is from my data. So I can create a control using that parameter. So let's say I can have select member ID, and I can pick how I want it to. So in this case, it's a drop down. I can pick the data sets. I can pick what field it is attributed to. So let's say I wanted a ID as a field. If let's say I wanted to hide the select all options here and default it to this particular member ID. So that's what it is doing on the top, if you see on my panel. So, and if, as and when I select these values, it will play interactivity within my insights, and it will filter out on my insights once my filter is also been built in. So we'll do that now as a next step. So as a first exercise, let's create one first visual. And this time it would be more of like I can take into account all these measures that we have as part of the data that we pulled in from the fitness details. Taking into account, so let's say I have total distance as one of my metrics, so I can pick that total distance. It gives me how much this person has traveled. Let's take an average of it, and in this case, seems like on an average every day is traveling 4.57 miles. We can account for that, and also we can change this instead of KPI into maybe a cause chart and define that. And we can set the range. It could be 0, and I can set up to certain range. So usually for any adult in a good health conditions, they will travel between 10 to 15 miles per day. So on a that's the health industry standards. So keeping like 10 as just a notation here, I can pick the 10 as a number, and then with that I can set it up. Also on top of it, we can set up the conditional formatting here. And let's say I wanted to set up foreground color for the arc and apply certain rules. Could be greater than, if it is 7, I can put my colors here and then add further conditions. Greater than equals to, let's say it's 5, then maybe other notations could be green. And again, if it is less than 5, I wanted to put the notation as amber. So I can apply those conditional rules, create my my visuals corresponding to that. Also, I can apply a filter using the parameters. Again, QuickSight allows you to link your parameters to your controls and then build your interactivity. There are other actions and other key components, other features which play a key role. We'll not go into the specifics on that. Just wanted to highlight here a few things. So here, let's say In this case, I wanted to put a filter on ID. I can pick the column as ID and then define what my custom filter was. I can pick the use and parameters here. And since we created already a parameter, it will get applied. So as and when the value is selected from the top, from my drop down, it will basically apply that to my visuals. And again, this can be applied to all applicable visuals. That's something we can apply that. Let's go in and create some set of other visuals as well. So usually on a fitness dashboards, you might have seen that we track some of these KPIs. Could be one is total distance, as we have already captured. And then we can track it by activity. So let's say I take the by activity date, and with that I can always find it out how my activity is been trending for this particular person. Again, the filter gets applied because it has been set for all applicable visuals. And if there is any further formatting, if I wanted to do, like for example, I wanted to take away the zoom, I can. And if I wanted to set up my x-axis and certain width and all, I can do that. I can create a duplicate. I can duplicate this particular visual and also build some other set of other KPIs or another trends. So in this case, let's say take into account calories. This is calories burned for this person. So both calories, we have calories burned and calories intake. So we can even take into account for both. But as of now, for this exercise, let me just take into account the total calories. And it seems like I can remove the other one. It could be done in one line chart comparing all, but usually for a fitness dashboard, it is better to provide the insights, show each and every trending for all these metrics to get that better visibility on how this person fitness is. Again, I can take into account another set of, I can duplicate that and pick another few other metrics, like average speed could be 1. So I can just replace that. Another, I can take into account one last one could be, and before we move on to the other areas. So this is average heart rate. I can provide that as well. And so these are all metrics we have created, all these prints. And as we were doing it, so QuickSight is also creating a set of insights for you and using our machine learning insights. So like for total distance, there are certain insights that have been created. So it seems like highest day reported was on January 27. If I wanted to add to my analyses and wanted to show that as part of my dashboards, I can do that. I can pick, let's say, another set of other metrics, could be a day over day change. That's another, giving you all the insights how it has been trending, what was on February 12 versus how the person, how much he has traveled from between February 12 versus the latest data that is on February 13, I believe, 12 of February 11. So it does that comparison out of the day. And again, you can make that aggregations change to date, to month as it's required. Let's pick another few insights. Like for example, we did it for total distance in case I wanted to see for calories. So again, inside there are forecast insights also, which has been built. And also on these line trend, I can add a forecast as well. So that's another functionality, another machine learning insights capability, which QuickSight is providing you out of the box. So here I'm adding the forecast. Let's say I wanted to take out the title again, and I wanted to place it, stack them one after the other in this case, and as part of my analyses. So let's do that here quickly and resize a little bit so that it fits into all my and aligns with all my other visuals that we are building in here. We can also account for other, like we have used so far the fitness data. Same way I can pull in, and the user profile. So if you see the user profile is coming in from the DynamoDB, all this fitness data is being coming from my Azure. Same way we have a nutrition data. So I can create even a visuals using my nutrition data, or I can have a visual which has both of them. So let's take into account nutrition data. For example, if I wanted to compare the calories intake for a person over a time, so in this case, I can take the date and then also wanted to see how the cholesterol levels are. And let's say in this case, I wanted to pick a different visual cluster bar chart. I can pick that, and I can also define like which one has to go for the lines versus the bar. I can define that, and you would get that trending chart along with that. And again, these are going to be for a specific person, as we have applied that filter here. We can do that way. Just one more last visual before we go into the next step. And that would be more of like, we can create a table comparing some of these other metrics. So for example, I can take into account again the date, activity date, and let's say I wanted to aggregate this time by week. I can pull a week here, so it gets aggregated by week. Now I can take into account, let's say, what the fiber level of the person is, or in this case, what the glucose level is, or let's take another one, total, how this total fat looks like. And let's say I wanted to create a table out of it. And in this table, if let's say I wanted to have a data bar to add more visibility to it. So for example, I can pick the attributes, add a data bar correspondingly to each of them. So to get that, like it visually, it gives a better representation and compare, like it can show me over the week how the things have been trending. Seems like in that particular week of February 12, the total fats consumption was very high. And seems like in the total fibers were high. And then again, we can add a cholesterol levels, sugars levels, and every other things and put that together. So that's pretty much how we can create our analyses. And also if there is any themes, so seems like I have a one theme here, I can apply that theme, and then it will basically, based on your standards and all enterprise level, you can easily apply those themes, how it should appear to be. And also you can add a title. It could be a text or it could be a title on the top. So for example, here I wanted to say fitness dashboard and add it on the top of all my visuals. I can very well do that and resize that a little bit. And even I can make that as centric. So I can go for it, align that centric. I can change what my size it should look like. I can change how the colors and all, everything. I can control that within my text print. So this is how you can build analysis. You can even add more interactivity like drill downs and actions and everything. So this is more of to give you a high level overview how you can pull the data from multiple sources and create quickly in a few matter of minutes. As you have seen, we were able to create these set of insights, and we can again do the actions, navigation actions, and create more detailed level data and have the navigations between the sheets and everything. So I just wanted to showcase, like, since as part of the exercise, me and Salim was working on and looking into the data, what kind of insights we can create out of it. So just an example and as a reference, we can create this kind of insights. And again, as we were pulling the particular person ID, I can click on a person, like how the average miles it has been over time. And as you do that, all that, you can see the person's names, details, everything, how my daily distance being traveled, what my calories looks like, intake versus if you wanted to compare with other metrics. And also, like in this case, if we wanted to compare the nutrition data with other members, we can easily pull that data and using a radar chart. That's another set of visuals that you can completely look at the variations of different metrics by different people, right? You can do all that comparisons, and again, based on the interactivity and all, it can do it. And as we apply these filters, all these insights are also getting reflected, or getting showcasing what based on the insights, what person's what is the health metrics of this person is, right? So this is about like how you can create an analysis and then create a great visuals, and then putting together a great dashboards, and then you can publish and share that with your end users. You can also do a one-click embedding out of it. You can also create a paginated reports with using this dashboard, or maybe using the same data source that we have. You can create your reports and again schedule it and send it across to the end users. Check on the time. So seems like we covered on the insights part. Now let's get back into some of the key considerations. And let me share my slide here. So some of the key considerations that we all thought through and we want you to highlight as part of the sessions, and which can be very useful for you, is the very first one is on the firewall settings. As you do it for Microsoft Azure Synapse or Google BigQuery, you have to set up you should allow your VPC, AWS VPC, to access through the VPN or a NAT gateway based on the control policies your organization provides you. So you can do it either VPN or through the NAT gateway. The next is on, as you might have seen, that there are few, like you can pick the attributes as part of your data sets which you want to have it expose it as part of the analysis and allow the developers to create or authors to create your insights. So always take a look at it if there's any unused attributes. So try to remove that, or if there's any data sets that you may have used it in the past but have no visual associated with the dashboard anymore, then adding it to the metadata payload would be unnecessary. So it's likely to impact the dashboard performance and all. So try to remove any unused data sets or attributes from your analysis, from your data sets, or from your analysis. The third one is on the Spice utilization. So you should utilize the capability of Spice as much as possible because it will boost all your overall performance. As Spice manages the scaling and also is caching the results and also doing a cost optimization for you. Like you're not running a query each time your interaction is happening against the sources. So always pull the data into a Spice, and that's our recommendations. And again, on the row level calculations, so anytime, like you might have seen that I created an activity date, that's more of required at row level calculations, and there's no need to be created in analysis. So anytime you see a row level calculations, always try to move them as part of your data sets, as part of your data prep layer, and that will enhance our performance and take away the overload. The last key on the row level and column level security, that's again, anytime you do a row level security or column level security, it requires the lookups to take place before any visual queries are issued. So when possible, try to limit the number and the complexity of your rules, your data set, and this will help lookups to execute faster. And also, if you're using a direct query, if you try to use a direct query, make sure that your queries are optimal and the data source you are querying is scaled appropriately upfront. So that's a key consideration from our end. Next is we wanted to highlight on the references. These, I will not go into the specifics of it. These are readily available on our AWS documentations. So one is on the Athena data source connectors. As you have seen, we covered the 3 Athena data source connectors, but there are other connectors also available. And if you wanted to explore that, we have that as part of it. So that's something we just wanted to highlight here. There is one blog that we have written, and it's again performing the multi-cloud analytics, and Salim has played a key role there. And that's where we thought of taking this initiative and exploring and sharing it with all you as part of this learning series as well. So you can go through this particular blog, and it is essentially going to be very helpful at covering all the aspects that we have done it so far. It's very detailed, and again, will be a good referring factor for you. Community link has already been shared with you. Yeah, and from there, you can always go and see what's new in the QuickSight, new features, new upcoming events that we are launching. So that always you can refer. Demo Central is another thing. If you're not familiar with that, that's our public portal where you can access our dashboards, sample dashboards based on the industry specific dashboards we have. We have some certain tips and tricks that you can follow through and see how that has been done. So for example, if I have wanted to see a particular tips and tricks and I wanted to see that, you can hover around and click on this analysis tab. So within this particular session, it will create your analysis, allow you to look at the analyses, and if you make the changes, you would be able to see that. So it doesn't impact the entire, because it's a sandbox environment which is allowing you to do that. Next is on the Learning QuickSight. These are workshops. We have that, and we will put it together. Deepak must be, he's already sharing these links. So you can refer that if you have to go through Author workshop, Q workshops, or any of the embedding workshops. This is going to be very useful and handy. Then on the pricing, that's all available on our documentation sites. This lastly on the feedback part, I believe that feedback link is already there. You can provide your responses, what kind of topics you're looking for, and how this particular session has gone, and whether it's been useful. If there's any feedback you can share with us, it will be, we will be able to take that your feedback and enhance our experience on the learning series going forward.